Hello and welcome to my quiz on velocity time graphs. There are 15 questions. You just need a pen and a piece of paper, but you can use a calculator. And don't forget, you can pause if you need more time. So let's get started. Question 1. Question 2. Question 3. Question 4. Question 5. Question 6. Question 7. Question 8. Question 9. Question 10. Question 11. Question 12. Question 13. Question 14. Question 15. That's the end of the questions. Let's move on to the answers. Question 1. The formula to find the acceleration using a velocity time graph is acceleration equals change in velocity divided by time taken. Question 2. In the first 3 seconds of her journey, the velocity is increasing steadily as time moves on. This is called constant acceleration. Question 3. In seconds 3 to 7 of her journey, the velocity doesn't change. This is called zero acceleration. Question 4. In the last 4 seconds of the cyclist's journey, the velocity is slowing down steadily as time moves on. This is called deceleration or negative acceleration. Question 5. In a velocity time graph, we calculate the area under the curve to find the distance travelled. In this case, the 3 sections add up to 30 metres. Question 6. To calculate the acceleration in the first 3 seconds of her journey, we use the formula acceleration equals change in velocity over time taken, giving us 1 1/3 metres per second squared. Question 7. The acceleration between the 5th and 6th seconds of her journey is 3 metres per second squared. Question 8. Acceleration that has a negative gradient is called deceleration. In this case, the deceleration is 1.75 metres per second squared. Question 9. When a graph curves upwards in a velocity time graph, it's called acceleration. Question 10. When a graph curves downwards in a velocity time graph, it's called deceleration. Question 11. In order to find an estimate for the acceleration at 2 seconds, you need to start by drawing a tangent at that point on the curve. You can then make a right-angled triangle out of 2 coordinates on that tangent and then use the formula. In this case, we get acceleration equals 1.12 metres per second squared. You might have a very slightly different answer, but that's okay. Question 12. In order to find the total distance Julie travels before stopping, we need to find the area under the graph. In this case, they all add up to 35.5 metres. Question 13. In order to find the distance the car travelled, we split the area under the curve into a triangle and 3 trapeziums. This will be an underestimate as the area under the curve is larger. In this case, our estimate for the distance the car travelled is 15.4 miles. Question 14. Notice in this graph that the velocity is in miles per hour and the time is in minutes, so the areas underneath need to be worked out in hours. Therefore, the distance covered by John in the first hour is 3 miles. Question 15. We know from the previous question that John travelled 3 miles in 1 hour. So we need to work out how much he travelled in the last 20 minutes, or third of an hour. When we add them together, it should equal 1, or all the areas together must equal 4. When we do that, we get x equals 2 miles per hour. Well, that's the end of my quiz on velocity time graphs. I hope you enjoyed it, and I hope you come again soon. Please don't forget to hit that subscribe button. Bye!